Good morning, everybody. Next topic of sixth unit is subroutine. And see, we know, as I already explained, that a subroutine is a program, is a group of instructions which are written separately from the main program to perform a specific task that occurs repeatedly. So, here, let us assume this is a main program. Main program. There are many number of lines are there, each and every. This is in mnemonics. In between, let us assume this is a main program. In between, here we called subroutine. We called subroutine to perform a delay function. Let us assume delay function is. So whenever call instruction is executed, the program sequence is shifted to the subroutine program written separately from the main program. This is a subroutine program. And this subroutine program is defined as the group of instructions written separately from the main program to perform specific function that occurs repetitively. See, if we don't write this subroutine program separately, let us assume timer program is there. So for every 60 seconds, 1 minute should increase. So we have to provide a 1 second delay between each and every uh, for every seconds we need to provide a 1 second delay. For every 1 minute we need to provide a 60 seconds delay. So therefore, and definitely here in timer or a counter, so we writing a program to create a 1 second delay or a 60 seconds delay or 60 minutes delay for each and every number, each and every hour or each and every second, the length of the program will become very fast. So the troubleshooting becomes a very difficult where exactly our loop is not executing properly. So this 1 second delay, we need to call a 60 times to increase the 1 minute counter. To increase the minute counter by 1, we have to execute this 1 second delay by 60 times in case of clock program. So therefore, writing a 60 times of 1 second delay program in main program, the program length will become very vast, and the program memory size is also increases very high. So therefore, to repeat 1 second delay for 60 times, we call only just by calling subroutine program by instruction call, we can shift the program sequence to the subroutine program where 1 second delay is written. After 1 second delay program, so again our program should jump to main program. So therefore, each and every call instruction in subroutine program, return instruction is also there. This return instruction changes the sequence of program to program sequence from subroutine to the main program. So like this subroutine program is very important. Uh, this is mainly used to avoid the repetitions of small programs. The structure of subroutine, this is a structure of subroutine. And wherever the call instruction is executed, definitely the subroutine should end with a return instruction. The concept of subroutine mainly used to avoid the repetition of small programs, uh, and subroutines written separately and stored in the memory, and they are called in various points of program, various points of the program using call instruction. And this is all about uh, subroutine. Subroutine, to understand the clear concept of subroutine, first we need to understand uh, first we should concentrate on push and pop instructions used in 8051. And this push and pop instructions here, when call instruction is executed. So what is the function of program counter? Program counter increment, after execution of instruction, it increments by 1 and shows the next instructions to be executed in a main program. Now, whenever call instruction is executed, the program count, this call instruction is a 3-byte instruction, and the program counter is incremented by 3 times, 3 locations. Now, in that first one is opcode, and second two bytes, 3 bytes, no, total 3 bytes. First byte is for operand, uh, not opcode, and second and third byte is the 16-bit address, target address of subroutine, where exactly we need to jump. And this instruction here, so therefore, whenever after completion of subroutine program, it has to jump to the main program. So therefore, main program counter address should be stored in stock, and this stock works on the stock will be works on based on 2 instructions in 8051. Those are push and pop instructions. So to better understanding of subroutine concept, we should concentrate on push and pop instruction, how those gets executed when call instruction is executed in a main program. So first I'll concentrate here. Wait, I'll concentrate on operation of push and pop instructions. Next heading is operation of push and pop instructions. So your push and pop instructions or stock related instructions. These instructions must be used direct addressing mode. So therefore, push, and we need to mention the address in instruction itself. So therefore, push and pop instructions are direct addressing modes, and no flags are affected. Why? Because only data transfer. While data transfer, we don't any flags will be affected, and data moves between areas of internal RAM or called as stack. So data will be moved internal. See, whatever the program counter address is there, that should be pushed onto the internal memory, where is a stock. The stock is nothing but a group of internal RAM memory locations. Therefore, the program counter address, whenever call instruction is executed, the main program sequence should be stored in a stock. Whenever return instruction is executed, again program counter is loaded with a stack pointer address, and by that program counter knows after completion of subroutine program where it has to jump, means again it main program only. The starting address of the stock in 8051, the stock pointer, every time if we reset the 8051, if you do the reset button, if you press the reset button on 8051, the stock pointer always shows 807 address, 7H address. And after execution of push instruction, the contents of stock pointer, the contents of registers saved onto the stock. Here, after transfer of, after execution of push instruction, the contents of registers, let us assume push or 3. Otherwise, directly here we need to mention direct address. This is not register addressing mode. So therefore, this kind of instruction is invalid in 8051 instead of R3. So what we are going to do, we are going to push this contents of this R3 register onto the stock. So therefore we need to write push 03. This push 03 is a direct addressing mode. The address is directly mentioned in the instruction itself. Now this 03 indicates R3, 03 locations. What is the 03 location? The name R3. So this instruction is invalid, but this instruction is valid. But both performs the same function only. So register addressing is not valid on push and pop instructions. Rather, direct addressing is valid. So therefore, push 3 indicates the contents of R3 location, R3 registers will push onto the stock, on to the stock. So here, while pushing onto the stock, initially the stock pointer position is 07H. While executing this push instruction, this stock pointer should be incremented by 1. SP plus 1, it becomes 08. So 08, in a 08, the contents of 03 locations will be pushed onto 08 location. Let us assume in R3 lo emundi 10 ఉంది అనుకుందాం 10H. Now push 03 అంటే this 10 content will be pushed onto the stock whose address is pointed 08H, like this. If we write push 02, now the content, let us initially assume that 02 R2, the contents of R2 is 08H. Now push 02 indicates that now stock pointer is incremented by 1, so it becomes a 09. Now the contents of R2 register, contents of 02 location is pushed onto the stock whose contents are 08H, like this. See, I'll explain this with the help of diagram here, with the help of some small program. And before a program, I'll mention the salient points of this stock pointers. Here, stock pointers basically will available locations for a stock pointer is 08H2, 1FH. See, this total are 24 locations will be there. 24 locations of internal RAM. Most generally used for stock operations. Used for stack operations. And next, if a program needs more than 24 locations, and here from 20 to 2F is a bit addressable area, bit addressable internal RAM. This is a bit addressable internal RAM. So we can't use these locations. So where from 30 to 7FH we can use these locations done with here move stock pointer. So we need to move the stock pointer to a specific address with the help of these instructions. Move SP immediate 30H. So from 30H onwards, we can use as a stock pointer locations now. Next, in a program, number of pushes and number of pops should be equal. In any program, while executing the subroutines, the number of push instructions should equal to the pop instructions. And this is very, very important. Otherwise, our main program, so our program sequence cannot return exactly where the call instruction is ended in a main program. So therefore, total number of push instructions in a program should be equal to the total number of pop instructions. Here for next we'll understand this push and pop instruction with the help of programs. Now first I'll write program here. I'll write a program. So here move or not, move or 3 comma as 42h. Next move or not comma as 50h. Next move or 7 comma as 58h. Move R1 comma as 3fh. These are the instructions. Next, what do we do? Push 3, push 0, 3 or 3, whatever it is. Push 0, push 7, push 1. Here, what happens to this address? Say initially, the stock pointer will be initially at 07 location. This is 07 location. Next 08, 09, 08, 0B, and so on like this. So stock pointer will be incremented by 1 while executing the push instructions, and it will be decremented by 1 while executing the pop instructions. So therefore, next after after these instructions, initially R3 is loaded 42, R0 is loaded 50, R7 is loaded 58H, R1 is loaded 3FS. These are the contents of this registers or locations, internal locations of 1 location, 7 locations, 0 locations, or 3 locations of internal RAM. These are the contents 42, 50, 58, and 3F. Now, after executing push instructions, first push 3 instruction is executed according to sequence manner. This program is executed sequentially. After execution of push 3 instruction, this stock pointer, what is the stock pointer value? 07. Now it is increases to 08. 08. So therefore, now stock pointer is 08. 08. Next, what is the 3? Push 3 means the 3 location, the contents of 3 location will push on to the stock. Stock is pointed at 08. Why? Because once for push instruction is executed, stock pointer is incremented by 1. This becomes SP plus 1. So therefore 8. Now push 03 means the 03 location contents will be pushed onto the stock. So 03 is nothing but 42H. Therefore 42H will be pushed on to 08 location. Next, after execution of push 0 instructions, again after every push instruction, the stock pointer will be incremented by 1. So therefore, this become 9. If it is 9, now stock pointer is pointing to the 9 locations. Push 0 means 0th location contents will be pushed onto the stock. 0th location is a 50H is there. Therefore 50H will be pushed onto the stock, and stock is pointed on 09H. Next, after execution of push 7, again stock pointer is incremented by 1. So therefore 09 will become 0A. This is the stock pointer. SP is pointing towards a 0A location. Push 7 means the R7 contents of R7 is pushed onto the stock, and stock is pointing on 0A locations. Therefore, R7 is 58, and 58 it will be pushed onto the stock, and stock is pointing at 0AH. Again, after execution of this push 1 instruction, again a stock pointer is incremented by 1. Previously it was 0A, now it is increased to 0B. Stock pointer is pointing to 0B locations. Now the one location, the contents of one location is pushed onto the stock. Stock pointer is pointing on 0BH. One lane will be 3F. So 3F will be pushed onto the 0BH. Like this, push instructions will be executed. Every push instruction, stock pointer will be incremented by 1, and those contents, the address is mentioned on a push instructions. address of those address of those contents will be pushed onto the stock, and where it to where when which location it is pushed onto the stock, which is represented by stock pointer. And after execution of every push instruction, stock pointer will be incremented by 1. Now we'll see the sequence of pop instructions. What happens when a pop instruction is executed? Similarly, here I'll write a program. See here, what are the contents initially? The initial contents are, I'll take this same program only. 08, 42, 09, 50H, and 0A is a 58H, and 0B is 3FH. How many instructions are there? Total after here these are 08, 09, 0A and 0B locations. Now I'll write how many push instructions are there? 4. So therefore we need to write a 4 pop instructions. I'll take pop 07. Means first while executing here, first it retrieves the data from the stock. First, it's very important. What happens initially, this while executing the push instruction, first stock pointer is incremented by 1, then the data will be pushed onto the stock, and the address which is mentioned in the push instruction, the contents of those address will be pushed onto the stock. Initially it incremented by 1, again pushing. Now while pop instruction, the pop 07 instruction will do, first it retrieves the data from the stock and again decremented by 1. Initially it retrieves the data from the stock and again it is stock pointer will be decremented by 1. Once again I am repeating, while executing the pop instructions, first it retrieves the data from the stock, pops the data from the stock into the address which is mentioned in the instruction itself. 07 means 07. Whatever the data present in stock pointer points, presently stock pointer points to 0B location. In 0B locations, 3F data is there, that is retrieved onto the 07 location. That process will be done first. After that, stock pointer is decremented by 1. Okay. Now see, pop 07, after while executing the pop 07, first stock pointer pop instruction will go to the stock pointer, and stock pointer is pointing to 0B location, and 0B location the contents are 3FS. Now 3F will be loaded onto 07 location. So that means R7 is loaded with 3FH. This process is completed. After this process, now the stock pointer should decrement by 1. Stock pointer decrement by 1 means previously it was 0. Now it is 0A. Stock pointer pointing to a 0A location. Then if I write another pop instruction, pop 02, let us assume, then first it retrieves the data from 0A locations. In 0A locations, what data is there? 58 is there. And 58H is retrieved onto the 02 location. Means R2 is loaded with 58H. After that, stock pointer is decremented by 1. So therefore, now it is stock pointer is pointing at 09 location. And if I write again pop 01, right? Pop 01, now what happens? it retrieves the data from the stock pointer. Stock pointer is showing 09. 09, the contents are 50H. 50H is loaded into register R1. 01 means R1 register only. So R1 is loaded with 50H, and after that stock pointer is decremented by 1. So while next, if I write a pop 05, right? Pop 05, first initially stock point retrieves the data from stock pointer. Now the stock pointer, previously it was 9, decremented by 1, so therefore it becomes 08. 08H. Stock pointer is pointing to a location of 08H. Now, what is the contents of 08? 42H. If I write a pop 05, this 42H will be loaded onto R5 register. 42 or 42 will be loaded into R5 register, and next stock pointer is decremented by 1. Previously it was, now it is 8, now it is decremented by 1, 7. Here every instructions, always after completion of push and pop instructions, the stock pointer should always be present at 07 location only. After reset or equal number of push instructions and pop instructions are executed, the stock pointer address should be only at 07 location only. It should not come down, and it should not uh, at any instant of time the stock pointer is not pointing to 06 location. So definitely, therefore this stock pointer, this push and pop instructions are very important. The initial starting address of stock pointer is 07H. From 08 onwards, it stores the data, it pushes onto the stock. Stock works on the principle of LIPO. LIPO means lost in, first out. Lost in, first out. సో ఇక్కడ లాస్ట్ లో ఏం డేటా పుష్ చేసినాం, 3F ని చేసినాం. మనం ఇక్కడ ఇనిషియల్ గా ఏం డేటా వచ్చింది R7 లో, ఇనిషియల్ అంటే లాస్ట్ లో ఇన్ అయిన డేటా ఫస్ట్ అవుట్ అవుతుంది. సో ఇదే లిపో ప్రిన్సిపల్. ద స్టాక్ ఇస్ వర్క్స్ ఆన్ ద ప్రిన్సిపల్ ఆఫ్ లిపో. And this is all about a push and pop instructions regarding stock related operations. And I'll stop here. Next I'll record another concept of another concept